Capable of eye-catching gymnastic feats, lightning-quick machine learning, and slick dance floor bobs, Boston Dynamics robots are truly a modern-day technological marvel. Just how Boston Dynamics build their robots. The most striking feature of Boston Dynamics' more famous latter-day creations, the adorable dog-like Spot and the swole, stormtrooper-esque humanoid Atlas, is that they walk on legs. Boston Dynamics' decision to go down the route of legs instead of wheels or caterpillar tracks was taken early on in the genesis of the company. Its founder and chairman, Mark Raibert, was for many years an academic, serving as Professor of Electrical Engineering and Computer Science at MIT and Associate Professor of Computer Science and Robotics at Carnegie Mellon University. Let's look at the software involved first. When most people talk about robot software these days, the subject of AI, artificial intelligence, usually crops up. But Boston Dynamics take a subtly different approach, emphasizing instead what they call athletic intelligence. Athletic intelligence refers to the automatic, almost subconscious processing most of our brains perform whenever we move. In order to acquire athletic intelligence, the robots first need to be equipped with a means of assessing the terrain in front of them. In the case of Atlas, clever LiDAR sensors, basically radar but using light, do the job. Spot, for its part, uses more conventional cameras alongside sophisticated 3D sensors. On the hardware side, Boston Dynamics robots perform their deft physical tricks thanks to a finely calibrated network of internal hydraulics. On earlier iterations of robots, this hydraulic fluid was pumped around the body through bolt-on tubes. But engineers at Boston Dynamics' Waltham, Massachusetts headquarters figured out they could make their components quicker, lighter, and more reliable by 3D printing robot body parts with hydraulic channels baked in. So a leg, for example, will carry hydraulic fluid within its very bones instead of relying on cluttered additional piping. For now, anyway, the humanoid Atlas robot is a strictly R&D only project for Boston Dynamics. Spot, on the other hand, is Boston Dynamics' first robot intended for proper commercial rollout. Spot can walk, climb stairs, avoid obstacles, navigate challenging terrain, and autonomously follow preset routes out of the box without needing constant input from users. But ingeniously, for future commercial applications, Spot can also be upgraded and modified. More subtle adaptations, such as an automatic command to pause working when a person is nearby, can be added at request. Mark Raibert has suggested his ultimate dream is for Spot to become a platform for other developers and industrial users to make their own distinctive mark on. Atlas was originally created using funding and oversight from the US Defense Advanced Research Projects Agency, or DARPA. This military backing obviously helped advance the progress of robotics. As it happens, Boston Dynamics' main project for the US government was a larger version of Spot, known as Big Dog, intended for service as a pack mule in war zones. Big Dog was sadly discontinued in 2015 after military top brass decided its gas-powered engine was simply too noisy for active duty. Boston Dynamics has since changed hands a few times, owned at various points by Google parent company Alphabet, who sold the firm in 2017 to Japanese investment conglomerate SoftBank. As of December 2020, SoftBank is handing the reins of the company over to the South Korean auto giant Hyundai, whose ability to manufacture at scale will hopefully bring Boston Dynamics robots into the mainstream. For now, though, Mark Raibert and his team will continue working in the lab and racking up those patents.